Welcome to HB Tuner's Ford Gen 1 Coyote Training Part 18. In this training module, we're going to take a look at dialing in our MAF curve using our VCM scanner, log data, and a histogram that allow us to repopulate our MAF curve so it's dialed in correctly. So moving into future training tutorials such as speed density, torque-based tuning, variable cam tuning, we'll have our MAF dialed in. We don't need to worry about it. So this is going to be the very first step in really getting things dialed in and adjust it properly for an aftermarket intake. Without further wait, let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at the MAF calibration tuning process in this tutorial. The last tutorial we went through and checked out the basics of the mass airflow calibration curve, understanding what we needed to do in order to turn off speed density so that we were following just on the mass airflow sensor so that we were able to go into this tutorial and start to actually calibrate it using our log data from our VCM scanner. This process is pretty straightforward. We're going to check out how this is going to go from idle part throttle and into full throttle. So let's check this out right now. So first thing I want to do is just go over quickly what we've prepped in our file from our last tutorial in order to start off and calibrate our intake that we have installed here. Now, we went from a stock intake with a stock MAF and we've put on a JLT intake still using the stock MAF sensor. So we went to a larger diameter in the MAF housing. The cross-sectional area has grown considerably with the JLT intake. Now we've prepped that using our Excel spreadsheet file. Let's jump into that right here. I have all of the popular intakes for the Gen 1 Coyotes right here in our list. I simply copied my JLT plastic intake calibration curve and we pasted it into our file. So that gave us a solid starting point. What we're going to do now is proof this calibration curve and make sure that it's actually accurate and it's tracking our airflow properly. So there's some things that we need to do in order to make sure that it's reading pretty close, and then we can update and further correct and refine this calibration curve. Usually, if we're starting off with one of these curves, they're pretty solid, but let's check this out and see what we can do here. So let's jump in. We're going to go back into our file here. This is the JLT intake. That's what I've labeled and named our previous file. So we've made all of our changes. Let's quickly go over those. Jumping into engine. And if we go over here, airflow, general, and then we jump into MAF calibration. We have our area here. We have our MAF adaptation. We turn that off. We have our cylinder air filter. We disabled that. And our cylinder air anticipation. Now, we also disable the desired air mass initialization switch by disabling this and disabling our anticipation. This turns off any of the speed density logic in the background. We'll find that the Gen 1 Coyotes have a hybrid system between the mass airflow and a speed density operation. We use a speed density to fill in the blanks if the mass airflow, if we're looking at a transient condition or a condition where the MAF might be unstable, the speed density is there to fill in the blanks, and it improves the fuel modeling and the airflow modeling that we have going on because it's always going to be tracking very, very accurate airflow modeling. Now, the problem with that is if we're trying to calibrate our MAF curve, the airflow versus period curve here, if we're trying to make sure that this is correct when we're at a particular period or digital frequency from the MAF signal, and we're registering a particular amount of pound per minute or grams per second, depending on the units you're going to be working in, it will we need to make sure that it's going to actually be accurate. If we have the speed density in the background combining with the mass airflow, it muddies up the waters and it's a little bit more difficult to track what's going on. So what we need to do here is proof that this curve is accurate, which is why we've made our subsequent changes in our tables in here. Now, one thing I am going to do before I go any further is actually turn back on the cylinder air filter. I had that previously turned off here in that last file. I looked back through some notes that I had from some previous Coyotes and looking at some previous calibrations. When I did the MAF calibration process, I actually had to leave this on. If I turned the filter off, it was really difficult to maintain an idle and I ran into some other problems. So I'm going to just leave this on. The filter filters the MAF signal. We're going to have to run with a filtered MAF signal just so it's stable and doesn't cause us problems. But we do want to, at this point, run with the MAF adaptation disable, the cylinder air anticipation disable, and the initialization switch disable so that we are running on as much of the MAF, sourcing everything from the table here as possible. Now, I'm going to go up here and just do a file and do a save. There's a few other things I want to talk about real quickly here. I prepped the file because we're going to be doing some full throttle pulls. There's some torque limiters and speed limiters that we need to get out of the way just so it doesn't hinder us when we go full throttle.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.